Hello everyone, welcome to my video on linear approximation. So let me begin by asking you a question. What's the square root of 4.04? So you might be staring at the screen blankly or reaching over for your phone or your calculator and typing in the buttons. But let me tell you, you don't need that. All you need is linear approximation. So let's go ahead and understand the theory behind linear approximation, and we could solve this without the use of technology. So first of all, we have our function here in green, which is f of x, some function. And we have, at the point A, we have this red line, which is the equation of the tangent line. This is our tangent line at the point A. So the observation that needs to be made is that close to A, notice that the difference between the actual function and the tangent line is very small. Like around this area here, the difference between the red line and the green line, let's say, it's relatively minimal. So we could approximate values close to A and get a pretty reasonable response. So let's say, for instance, the function f of x is square root of x, and the value of A is 4. Well, we know that the square root of 4 is 2. So f of A, this answer would just simply be 2. But if we shift away from 4, slightly to the left or slightly to the right, could we approximate what the value is? Yes, we could, using the equation of a tangent line. And that's the idea behind linear approximation. So let's look at the definition. So recall the definition of the equation of a tangent line. So the equation of a tangent line is expressed as t of A equals f prime of A times x minus A plus f of A. Now, by definition, the linearization, so we use the term linearization, of the function f at a given point A is expressed as the exact same thing. We just call it capital L of x is equal to f prime of A times x minus A plus f of A. So we're using the equation of a tangent line to approximate this function f of x, okay, at the given value A or some neighborhood of A. So in this example here, it asks us to find the linearization of the function f, which is given as the square root of x plus 1, at the value A equals 3, and use it to approximate our square root of 4.04. So let's use this function here to solve this without a calculator. So the first thing we're going to do is use our linearization formula. So solution. Our linearization formula is L of x equals f prime of A, x minus A plus f of A. Okay. So we have to go get our derivative, substitute A. We have to get our value A, which we actually have already. A is 3, so this A is done. And we have to go get f of A. So let's go ahead and do that. So going to get f of A is simple. We could start off with f of A. That's just solving for f of 3, right? Because our A is 3. And we're going to substitute it into our function f of x equals square root of x plus 1. So instead of writing x, we're substituting with 3, so 3 plus 1, giving us square root of 4, which gives us 2. We're using the square root function, so it's not plus minus 2. We're just using the top half, right? So the square root function looks like this. So it's just positive 2. There's actually the negative value 2, but it's no longer a function, so you have to either take the bottom half or the top half. Since it's positive in front, we're taking the top half. Next, we could go take the derivative. So f prime of x. And then I'll substitute A afterwards. So I'm going to start off by taking the derivative, then plug in my value A. So taking the derivative of f, let's first of all rewrite it as x plus 1 to the 1/2. Whenever we have a square root, we switch it to the exponent 1/2. And we're going to take the derivative of this guy, so I'm going to write prime. So if we take the derivative of this, we're using chain rule. Drop the 1/2, x plus 1, and then subtract the 1/2 by 1, giving us negative 1/2. And then we're multiplying by the derivative of the inside. But the derivative of the inside is just 1, so you don't even have to write it. Because the derivative of x is 1, the derivative of 1, a constant, is 0. So this is our derivative, and next we're going to plug in, we're going to substitute the value A, which is 3. So f prime of 3, this is essentially our slope. 1/2, 3 plus 1 to the negative 1/2. So we could drop the negative 1/2, giving us 1 over 3 plus 1. Well, there's still the 2 on the denominator. 3 plus 1 is 4 to the 1/2. 4 to the 1/2 is just square root of 4, which we know is 2. So this is 2, and 1 over 2 divided by 2 is 1 over 4. So we get 1/4. So the derivative or the slope of the line is, well, the derivative of f at this given point gives us the slope, which is 1/4. So the slope is going upwards because it's positive. So now that we found this, we have our f prime of a. This is done. We have our f of a. We just got our linearization formula. So let's go ahead and plug everything in. I'm just going to erase this. So f of a is here. So our linearization formula is equal to f prime of a, which is 1/4, x minus 3 plus 2. I'm just substituting all the information that we know. And the next step is we have to figure out the value of x to substitute in here. Well, what are we approximating? We're approximating the square root of 4.04. But what's the x value that we're going to plug in here? Because the square root of 4.04, you should think of this as a y value, or f of x. So what you're going to do before you substitute is you're going to set this equal to the equation that's given. Okay, so we're going to, think of it as a y value. So if we set this equal to our function, we substitute our y value into the function f of x. This is equal to square root of x plus 1. Because our job is to find the actual value of x. Well, what we could do now is square both sides to get rid of the square root. So if we square both sides, what we get is 4.04 is equal to x plus 1. Subtracting the 1 over on both sides, we get 3.04 equals x. This is the x value that we're going to substitute into our linearization formula. That's how we know what to put in here, because we're looking for an actual number to represent the square root of 4.04, or at least to approximate. So when we plug this in, let's go ahead and find our approximation to the square root of 4.04 without the use of a calculator. So square root of 4.04 is approximately L of, not x, we know the value of x, 3.04. And if we substitute 3.04 into this equation, we get 1 over 4, 3.04 minus 3 plus 2. This gives us 1/4. 3.04 minus 3 is just 0.04 plus 2. And then 0.04 divided by 4 is just 0.01 plus 2, giving us 2.01. So if you answered 2.01 at the beginning of the video, great job. That's awesome. But let's look at our calculator and see what the actual value is of square root of 4.04. So the actual value, not 40.4, 4.04. Using our calculator to verify our answer, it's actually, let me put an approximation symbol, 2.009975, so on and so forth. But as you could see, this is a really good, 2.01 is a really good approximation to 2.009975, seeing that we didn't use a calculator. So in this next example here, we have to find the linearization of the function f of x equals 1 over square root of x plus 3 at the value a equals 1 and use it to approximate to 1 over square root of 5. So without the use of a calculator, pause the video, try to solve this on your own. So the first thing we do is we use our linearization formula, L of x is equal to f prime of a, x minus a, plus f of a. So make sure this formula is memorized. We're going to start off by finding f of a because we have a again. A is that, it's the value 1. F of a, we just substitute a into our formula. So f of a equals f of 1, which is equal to 1 over square root 1 plus 3. Okay, this may look like you need a calculator, but you don't. 1 plus 3 is 4, square root of 4 is 2, so this is just a half. So f of a, the value of f of a is a half. Next, let's go find the derivative, x. So we're going to take the derivative of f of x. So the first thing we're going to do is rewrite it as 1 over x plus 3 to the exponent 1/2. So I'm getting rid of the square root, and next I'm going to drop, I don't want to use a quotient rule because we have a division here, so I'm going to bring this thing up. If you want to use quotient rule, that's fine. I'm going to bring it up and rewrite it as x plus 3 to the negative 1/2. Okay. I'd rather use chain rule. So because we're taking the derivative, I have to write prime to say I'm about to take the derivative. If not, you can't write f prime over here, they're not equal. And now we're going to take the derivative of this, giving us, let me do it down here, negative 1/2. We drop the exponent, leave the inside, x plus 3, subtract the exponent by 1, giving us negative 3/2, and then multiplying by the derivative of the inside. So the derivative of the inside is just 1. Okay. So this is our derivative. We could take one step further and rewrite it as negative 1 on top, 2 on the bottom, x plus 3 to the 3/2. Okay. So this is the derivative. Now we're going to substitute because we want f prime of a. So we're going to substitute 1 into our derivative. Let's do that here. Giving us negative 1 over 2, 1 plus 3 to the 3/2. Okay. 1 plus 3 is 4, so we get negative 1 over 2, 4 to the 3/2. How do we deal with 4 to the 3/2? Well, this may seem complicated, but it's not too bad if you do the right property, order of operation first. So the first thing I would do is the root. Deal with the root first. Make the number smaller, especially if you're not using a calculator to do this by hand. Don't cube the 4 first, because it doesn't matter which one you do first. You could either cube it or you could do the 1/2 first. I would do the 1/2 first. So you should think of this as negative 1 over 2, 4 to the 1/2, all that cubed, right? Because 1/2 times 3 is 3/2, so I can rewrite it this way. And the reason why I'm writing it this way is because 1/2 we know can be rewritten as a square root. So this is essentially just square root of 4. And we know the square root of 4. Square root of 4 is 2. So what we're left with is negative 1 over 2 cubed. And 2 cubed, we know it's easy to do. That's 8. Giving us negative 1 over, this is 8 times 2. I'm running out of room, so I'm just going to write negative 1 over 16. This is f prime of 1. Okay. So my advice is always do the root first and then cube it. Because if you have to cube it first, you're going to get it right. You're working with larger numbers. You'll eventually get the same thing. So our linearization formula is L of x equals f prime of a, which we got was negative 1 over 16, x minus a, which we know is 1, plus f of a, which was, oops, I erased it, was 1/2. So now that we got our linearization formula, let's go ahead and find the value of x that we have to substitute into our linearization formula. How do we do that? Again, think of this value that we're approximating as your f of x. This is your y value. So we set them equal to each other. Setting them equal to each other, we get 1 over square root of 5 equals 1 over square root of x plus 3. What do we do next? Next, to solve this, you're solving for x, you're essentially cross multiplying. We're going to multiply the square root of x plus 3 up here and the square root of 5 up here, giving us square root of x plus 3 equals square root of 5. Next, we square both sides. If you wanted to square both sides at this stage here, that would also work, that's fine. So let's go ahead and square it, giving us x plus 3 equals 5. Moving the 3 over, we get x equals 2. Okay. So this is the value of x that we're going to substitute in our linearization formula. So 1 over square root of 5, that's a 5, is approximately L of 2. That was the x value that we got here. So I'm plugging x, I'm replacing x with 2. So we're going to substitute that into our formula, negative 1 over 16, 2 minus 1 plus 1 over 2. 2 minus 1 is 1, so what we're left with is negative 1 over 16 plus 1/2. Finding a common denominator, we get, multiply the top and the bottom by 8 here. So we get negative 1 over 16 plus 8 over 16. This gives us 7 over 16. And this is the value that approximates 1 over square root of 5. So 7 over 16 with a calculator is approximately 0.4375. And the actual value with a calculator here of 1 over square root of 5 is 0.44721, so on and so forth. So as you can see, the approximation is very good. So this is to show that you don't need technology or a calculator to actually compute these values. We have good enough approximations that which you could do by hand. Example 3 says to use a linear approximation to estimate the value of e to the negative 0.1. How do we do this again without a calculator? So what's different about this example is that we don't actually have a function. We're not given a function to work with compared to the other two examples. So how do we do this? Well, what you have to do is anticipate or come up with a function yourself. What's a function that you can use to approximate e to the negative 0.1? What does this look like? So what you have to catch is that this looks like f of x is equal to e to the x. The function that we're working with is exponentials, e to the x. Okay. Next, what we need is a parameter a. What value of a is close to negative 0.1? So you could choose a value. The one that I would do is 0. Why? Well, if I substitute x with 0, do we know that value without a calculator? Yeah, e to the 0 or any number to the 0 is 1. So I'm going to use the value a equals 0. So what's difficult about these types of questions is coming up with the function and the value which we're going to approximate the one that's given, okay? And now we go through the same process. So let's go ahead and use the linearization formula. So L of x is equal to f prime of a, x minus a plus f of a. So we figured out f of a, again, a is 0, f of x is e to the x. So f of a is equal to f of 0, which is e to the 0, which we said is 1. So f of a is done, a is done. All we have to do is go get the derivative now. So we go get f prime of x. That's equal to, well, the function that we're working with is e to the x, so the derivative of e to the x, we saw this, we like this, it's just simply e to the x. And if we want to evaluate it at 0, well, that's just e to the 0, which again is 1. Okay, so pretty simple. This is done, this is done. So let's erase this and create our linearization formula. So the linearization formula that we have, L of x, is equal to f prime of a, which we said was 1, x minus a we said is 0, plus f of a, which is 1. So it's simply just x plus 1. Right? X minus 0 is x. We're left with times 1, just x plus 1, giving us this. So this is our linearization formula, and this is what we're going to use to approximate this value here. So e to the negative 0.1, we set it equal to our function. So e to the negative 0.1 equals e to the x. They have the same base, so when the bases are equal, their exponents are equal. So we get, this implies negative 0.1 is equal to x. We're going to take this and plug it into our linearization formula. So e to the negative 0.1 is approximately L of x, which is negative 0.1. And that's equal to negative 0.1 plus 1. Negative 0.1 plus 1 is 0.9. Okay, so this is our approximation. Let's look at the actual value. So the actual value of e to the negative 0.1 is 0.9048. So as you can see, the approximate value is very close to what the actual value is. This should convince you that you don't actually need a calculator to solve these problems. You could do this by hand, and that your mind is more powerful than technology. So I hope you enjoyed the video, hope this helped, and I'll see you in the next video.